All right, hello everyone. This is Junchan, and we're back on stream for some more Purescript. And let me do a little bit of housekeeping here and make sure that we have. My keyboard is acting up. Make sure that we have our logs copied for today, including our prototype log. So let's continue where we left off yesterday. So we actually succeeded in hooking up the original formulation of Purescript React Explorer, which we went back to. And so let's go and check out the code. And I suppose this is not it. It should be this one, right? Yes. So quite a mix of a discovery and something I've been sort of intuiting or hoping all along, which is that it's really with this co-free pairing that is some of the essence of the comonadic UI pattern. We really only need, thanks to the co-constructor, which can create a monad out of any comonad, we really only need to specify the comonad, and then we should have everything else sort of available without needing to define any other type. We do have to define some functions or some terms for the monad, meaning the monad. So Purescript usually you'd find in like some of my earlier examples. Actually, if we go check that out, right here in the counter, for instance, define both the base functor for the free monad and then an interpreter as well. And then say that those were pairs. Here we're circuiting all of that stuff by only needing to specify the type for the comonad, and then we're able, through a little bit of sleight of hand, to apply code to the comonadic type, get the monad from that, and then through this combinator there and the basically some kind of pattern matching on the comonadic value that goes either one way towards put or the other towards get in that case, and making sure that we pass the continuation correctly and whatnot, then we're able to construct the put_line monadic value and the get line monadic value. And so that replaces, if we want to look at it from just a number of lines, it replaces with these like 8 or so lines what originally would count for something similar in the console experiment here. That wouldn't be fair to compare it here, but even here actually the counter example also has 2 constructors, so it's pretty equivalent. But here what we had to do was define the base monad, then put free in front of the base monad, then define the monadic values here with a lift, and then define the comonad, the base functor for the comonad, and then the co-free comonad from that base functor, and then the pairing. And we got there, and so that's about more than double the number of lines, right, if we want to go there. But obviously it's not just that, is that conceptually it's just so much more elegant. It means that you can choose to make the space perspective somehow the primary perspective, and in fact it wouldn't work the other way because there's no for every monad. So somehow the comonad is a more generative type that can, or actually that's not even, it's smaller than monads in the way that allows to derive a monad from every one of the comonads. And that's going to be sufficient for any case that I can imagine. I mean, clearly not from a math perspective, but from a programming perspective, I don't see where it's not. And, you know, it's means that instead of specifying our base functor as a sum type, we define it as a product type here as a record. So yeah, I can't see any. I mean, this is sweet. I really like it. And then we still have an interpreter to write. So maybe my comparison wasn't exactly fair. I think I was actually, well, no, it was fair because this didn't include the interpreter. The counter interpreter was here, so no, it was fair. And so our interpreter looks like this in this case. And so here we're not doing any effect. It's a pure interpreter at this point. And that's some of the stuff that we want to work on today. So the easiest way to do that is to change this carrier type to an AF, following in the footsteps of something that I was showing last time, and that I've been playing with in some of this other code that I've extracted there in this play folder. So here we see something very similar. Yeah, I actually took the base types from here. Here we have the co-console F, so what we can see is that here I actually use F string as the carrier type instead of F, and that allows me to define an interpreter here that's actually doing a lot of interesting effectful things. So we're going to do the same thing, but maybe just simply ignore the interface for now. I suppose what we maybe should do first is to just try and introduce F string as the carrier type progressively and see where that takes us. Get the types to align, and then from there maybe see how we whether we inject some of that older code. It might not be completely relevant because here we're in the browser. In my old code we were in Node, so we were using the Node readline interface. Here we'll use something else for the put get, and what I was proposing we do in the log is to just hook the kernel fault. Just go straight for the valuable stuff here and get us back on track. Okay, so let's just give that a shot. Okay, am I in the right place? I am. So did I already just do that? I replaced with F string. Yeah, I did, I think. So let's just try that. So yeah, our monadic value will be in F string as a carrier type. Actually, you know what? I wonder whether that's really necessary. It probably is. I suppose that the carrier type for the co-free comonad needs to be the same than the free monad, but who knows? It might not necessarily be the case. That would actually be nicer. So it would be an interesting asymmetry, but it would work quite well within our context. We have a type that doesn't care about whether it's going to have oh, I say that, but we will care here, won't we? We'll need put to be an F string, I think. Let me take another look at play again. Yeah, I suppose, let's see, console. So first of all, the getLine prime is an F string. So I suppose we did not have a putLine prime for some reason. Or putStirLine prime. It's apparently not. Interesting. So I did have a mix there of something pure and something effectful. Very interesting. Okay. So I'm importing this from the types module, I believe, and indeed it just takes a string. So it could be that we can just mix and match. Here getLine was returned in fx string, but put stir line didn't. And so that, but that didn't prevent me in this play example to have my put apologies, to have my put interpreter be in AF overall, which I think means that I could have used delay in here as well, which means that it does the trick that I was hoping maybe we could do, which is to in fact keep our, well, only introduce effects where we really need them. So if we don't really need it here, maybe we don't, and then we do introduce it here. And that's, in this case, again, I'm asking, does the monadic action really require the effect, or is it only the interpreter that does? And in fact, does this represent something that actually has some meaning? Meaning, do we allow external side effects to move us inside the space, or do we, which would mean that like here, the monadic action would be effectful, which could be interpreted as getLine need access to the external side effectful world in order to be realized. And then on the interpreter side, maybe the put stir line needs comes from the pure world because it originates from inside the application, which is a pure data flow. And then however, maybe the interpreter for put could have some effects or not. So then we have a lot of sort of switches to flick, depending on whether we want to activate effects in both either the monadic action or the interpreters for the movements in space. So that's quite an interesting thought. So what does it amount to, and how much do we want to test that assumption? I suppose we're still in the library here, so I think it makes sense to test the assumption here. And maybe we can, so the problem is that we can't really use the console example as is in this context here, because we're in the browser. Unless I suppose we made, no, in fact, in fact, that's all good. We just consider that the console is the text area. So let's imagine that the console is the text area, and then let's try to introduce effects in all 4 possible positions. And so I think so the natural one, okay, I think I'm realizing something maybe. Because here, there is effects built inside component. So here we are all pure, but the interpreter is pure. In fact, we could actually remove this and put it here if we wanted. But it's the hooking of the interpreter to an external side effects occurs here. So the on key press occurs from the effectful component that has access to the web browser. effect or event system, right? And then we pass it a value that, in our case, will want to be actually connected to the event we receive. And so let's go check out the Purescript code for that. Here we will be somewhere around here, maybe React, yes, on key press. That will give us a keyboard event, and we can use maybe for now the key in it. So let's just do key and then puts the line the key and see where that takes us with running Parcel, which should not need a Spago build because we're using the Purescript IDE. That should do a rebuild. We might need to reload here just to hook into Parcel's auto reloader. So if I, yeah, like, oh no, hold on. So now, so it might actually not have rebuilt. So let's create another terminal and Spago build -w for watch. And there's an error. That's the problem. Okay. So we are not matching correctly against the API. So we might not be receiving keyboard event on key press from P with React DOM props, which is where we're supposed to be, but maybe not the right version. Is that the issue? Oh wow, yeah. So let's see, what is the version we're using? React DOM. You know what? How do we do that? Spago ls then packages, a dependency of the project depths, and we have React DOM 610. Okay, so let's go there first, and then on key press, yes, synthetic keyboard event, and let's look at whether that API changes in the latest version 9. On key press, it doesn't. So let's just update. Is there a Spago command for that? Spago upgrade set. I don't think is what we want to do. Download all dependencies. Okay, so why is it pinned that way though is the question, right? It could be that I just have an older version. It could be also that some of that stuff actually requires Purescript version 0.14. I would like to move to version 0.14, but I'll keep this example simple. I'll try to get all my dependencies to Purescript 0.14 in the browser kernel for prototype. Here we're just we'll just try to do these tests, more conceptual tests. Okay, so on key press wants a synthetic keyboard event, which has a constructor, and yeah, that's a little bit unclear on how we deal with that. I take something that returns effect unit, so which is why we have to do pure unit here. So basically, puts the line stays pure, and we fake a no up effect here just to let it pass. Okay, well, that's all well and good, but yeah, how do we deal with a synthetic keyboard event? Let's see if there's some example. Maybe React synthetic events. Will that tell us how to deal with it? Visibly not. So let's go here, and it's going to be in docs. Synthetic event on tick. Synthetic event handler. Okay, I don't know that we on tick MK effect. Event prevent default. Blah. Do we need to do this? That's possible. They'd be related to dealing with basically a sort of a foreign type of sorts. Let's try that. It seems like it makes sense that that would be the pattern here. And then we shall do something like so. On key press, key effect, blah, and that's equivalent, the pure unit, except that we might want to prevent the default. That's going to be useful, and that's probably what this API allows to do, which the previous one probably didn't. And we put Sterling key, and but right, no, not exactly. We put Sterling. We need to send this. So there's a question about where we send it. Is it here now, or does send supposed to be effectful? Might be the case, and now I'm a bit worried about how coupled this is to the UI type. Let's take a quick look at it. UI being handler, so it's A2 effect unit, so I think we are actually pretty free with what we can do in here. So I think in effect what really this returns an effect fn1. You know what, I'm not sure that we're doing this in the right way. It's feels a bit strange. Synthetic event. Let's try it. So I'm not sure where to put my send. But maybe this is fine. Except we might want it to to return also to return pure unit. So let's just keep the pure unit here. Import event from React synthetic event. And make this key. Event at key. Okay, so what if I do this? You still no. Okay, in that case, Yes, so oopsie. Event.key, is that even a thing? Maybe. Right, so I'm still not, so we're still getting a synthetic event out of this despite the make effect, so then we haven't gained anything at all. On toggle, let's FMK props. Readme. How can I assess event target value? Pass event right to the target function. Okay, I actually don't understand. Revamp events. If synthetic event is a raw record. So, okay, so let's go back a bit in time here, because it could just be that we're missing the constructor name, and in that case, it's just very simple, that synthetic event just as a little wrapper. And we just need to put it in there. Synthetic event underscore, I suppose. It feels a bit weird to use that. And no data constructor, right? So if it's not exported, then we're obviously we're not in luck. Let's see. Yeah, no quick. Both seem to be potentially available. We need the data constructor. Did we? So that's from a row type. So maybe we actually need to deconstruct it with synthetic events, not synthetic event. And maybe we need a constructor. There's no data constructor like this. Okay, so no. But maybe we need a constructor for this, and then we need to call this underscore. I don't know, I'm flailing a little bit here. Yeah, apparently no data constructor for it. Hey Graph, how's it going? Oh, Purescript is totally basically Haskell, absolutely. What am I hunting for right now? It depends if you mean like specifically with this little local problem, or kind of more broadly. This little problem, I'm just trying to understand how to how to deconstruct an event that's provided by React, the React DOM library. Both. All right, I was on my way to answer both, so that's good. So yeah, so that's the local thing, is how to get the key that I pressed in the browser, right? Just to get my thing going. And then zooming out, this is me playing around with Purescript React Explore, which is Phil Freeman's, the creator of Purescript, sort of experiment or the discovery of a pattern in UI libraries, such that if you look a bit at sort of the math or the type behind it, how familiar are you with like things like free monads and comonads and co-free comonads, for instance? Yeah. Well, that must definitely be the one. So you are familiar with comonads? I'm happy to get down to it, but I'll show you the broader pattern that there's a slide that I like that I think explains a bit what the value of this formulation of UIs is, and it's somewhere in the middle of this deck. You haven't looked at it? You know Jachikava comonads for UI. Okay. Do you know you know the laws of comonad? Okay. All right. So that's all good. Yeah, I was there not very long ago. So completely on the same page here. Let me move to that slide that I like. Pairings for free. So what? I don't know, it's a little bit before that. Yeah, there you go. That's the one. To me, that's the power slide. It shows that basically this pairing pattern, which I'll go and explain, which pairs a monad and a comonad. So that's why, I've been asking you whether you know comonad or not. This pairing pattern just happens to represent like broad classes of UI libraries that we can know and like from the broader ecosystem of the UI library work, right? Like React in JavaScript, Elm, Redux also in JavaScript, and then Halogen is pretty used. This is kind of, I think technically it's not an adjunction, I think. But I think I'm a little bit above my pay grade here. But I think a monad arises from an adjunction, and a comonad also arises, but maybe from another adjunction. And it's just like this thing is a pairing. So I'm not sure if technically it's an adjunction, but I might be wrong with that. But yeah, it's kind of that, it's nicely symmetric, like a lot of those things that you find in category theories, right? And so that already feels a little bit powerful, right? The fact that you could say, well, actually React is the choice of a state monad and the store comonad as the two aspects of that pair, then that's like React. Whereas if you take free of reader and free of pair and free of and co-free of reader, then you get Redux and Elm. You're like, what? Crazy. You can get like this whole, like hype buzzword domain of people like that are all writing libraries using this thing just by the choice of a particular monad and a particular comonad, and that are paired. That to me is like, one of those things where I love functional programming is like, like the discovery of like deeper patterns. You're being loose. Okay. All right. Yeah. I'm the same. So, so you see here, the one that I'm interested in, and it's just because I guess it's one that I think you see also discussed quite a bit elsewhere, is the free co-free pairing, and with some kind of base functor. And the reason why I like that is because I kind of believe the hype train on free monads, which is that they're quite well composable. And then also in Purescript, there's other ways in which you can do sort of extensible effects with monads that are quite interesting. So it's really interesting to explore. But also there's something really pretty cool that arises, which is that there is this thing called Co that obviously Edward Met came up with. CQRS and event sourcing essentially state here with a bunch of yes, yeah, I love that. Yeah, in fact, I'm really trying to poke around that design space, because I think in fact there's maybe more. It's not necessarily just state T; it's actually the update monad. I think like each given event is supposed to be representing a sort of an incremental action on a state, and I think that that's supposed to be somewhat better represented by the update monad, because the state monad can arbitrarily replace your state, whereas in event sourcing usually you have a vocabulary of events that sort of change your state in a well-defined way. So I'm super interested in that side of things as well. I'm trying to join my intuitions coming from like the more CQRS ES side of the world with my more recent discovery of functional programming. To be honest, Ko-fi always has been a bit puzzling. Right. More natural way to look at Ko-fi is what it's a fixed point with a tag. Yeah. And free is a fixed point where you either have an element or a tag. Yeah, that's completely right. That's the definition. And then what arose for me in looking at this pairing at the application for Comonad is like a pretty cool intuition about the way that free and co-free pair, and that doesn't exhaust the ways in which you can use free and co-free, but it's a super interesting guiding intuition for me. So let me walk you just quickly through it, because this stuff is completely blowing my mind and I love it. So as I was saying, one thing that's particularly interesting and that comes in the blog post about Comonads as spaces by Phil Freeman before he wrote the paper. That stuff is something that was written by Edward Met, of course, which is that you can get a monad from any comonad, and it doesn't work the other way around. So if you have a monad and you put this combinator co in front of it, boom, there you go, you have a monad now from your comonad for free. And so that's pretty cool. So it means that if you start from comonads, potentially you have a bunch of stuff that you get, pun intended, for free, meaning you don't have to necessarily to write your monad, because as it happened, if the monad that you get by putting co in front of a comonad, so the comonad, right, is actually naturally paired with its source comonad. So if you put co in front of a comonad, then you get a monad that pairs with the comonad. So, okay, why would that matter? Well, because here is the way that you might want to play with this kind of stuff. Something that you might have seen elsewhere is defining which is very event sourcing. You define a vocabulary of your events and actually use events specifically within mine event sourcing there as some type where you have like different formulation of events together with their payloads, basically, right? And but that's when you write that, I don't know if you're familiar with this pattern, but that becomes a base functor for a free monad that you can automatically derive by putting free in front of counter events. Hyperfunctions. That sounds fun. I think I've heard of this. I'll take a look in a second. Let me continue my thought here. So you have this pattern where you put free in front of a functor, and that gives you a monad. And the intuition with that is basically, you know what you just say, a fixed point where you have either an element or a tag. Well, if you have an element, then in your monad, it means you're continuing to move forward, and you still have fuel to continue moving forward. But if you have your tag or your nil or your pure or your done, then you stop, which is kind of like return in your monad. So you have a way to just return a value instead of continuing a computation. And so that's the intuition here, is that when you put free in front of that base functor, free sort of adds in a hidden way, like done here, or return something. And then you can continue, kind of incrementing as long as you want, and then at some point you can just exit. And so this pattern of sort of using a functor, like that's pretty simple, like a sum functor like this, and then turning it into a monad just by applying free in front of it is kind of magic. But to me, it's something that's really rich in intuition, because I just like the fact of looking at the actions, the monadic actions in my applications, as something as nice and neat as like a sum type like this with a little a in addition. Pattern functors of sorts, exactly. And so and then usually what you'll then do is that you create like some basic combinators like change, count, and increment that will allow you to then use these as monadic values inside your application. So whenever you need to have an effectful thing, then you'll pass increment, and then that will automatically sort of call the proper constructor from your counter event type and make it like run like exactly like a monad, like you would like. Okay, so that's fine, and that's what monads are, and that's usually what we're familiar with, because as when we try to learn functional programming, we at some point we want to try and understand what the fuzz is with this monad thing. But what's happening in the other side, in the comonad world, where in here I construct manually a comonad that I call interpreter. And instead of a sum type, it's a product type. So here in Purescript, it's a record. So you see it has exactly the same sort of constructor, except that instead of being in a sum type, they're in a product type. And here I put cofree in front of it, and then I get a comonad. So that's exactly like the same symmetric pattern for from a sum type, you put free in front of it, you get a monad. From a product type, you put cofree in front of it, you get a comonad. Bang. So that's nice. And then here manually I say those pair, and then you can say specifically how they pair. And the whole insight from this comonad as space here is that basically this monad and this comonad, the way they fit is that the monad is a bit like the driver of like if you're sitting in the car and that you're steering the wheel. Like it's the part in your system that has the agency, the part that's kind of deciding to move left or move right inside the roads of your country. And the comonad represents the roads of your country. It represents the state space in which you're driving or in which you're doing actions. So So for instance, in increment is my decision, right, to turn my steering wheel to the right, for instance. And then the state space will say, okay, well, if you give me an increment, then I'll do +1 to the state space. So that's the intuition there. And to me, that's really symmetric. So, I really like these things because it seems like if I have something that's so neat and order, it'll make things much easier for me to understand. And I had this intuition, and I was just testing it yesterday, that actually I was doing too much work, that there was this co thing. So I should be able to only define the comonad side of things, and then somehow find a way to define the monadic values, and then without needing to ever define the monad, except by calling co in front of my my base functor. And actually it does work. So here I have basically very similar code. Instead of defining my free monad, I define my co-free comonad base functor here. And then I do this little trick in order to define my monadic actions. And then I define an interpreter that has this type, and it works. so that's super neat. Yeah, and so I want to continue building up on this pattern. And one of the things that I was doing right now is trying to find out how to add add effects to my interpreter. Because in some of the Tori project that I was working on early on last year, when I was playing around the first time with some of this stuff, which is a bit complicated, I was playing with having the AF monad, the asynchronous effects monad in Purescript, in order to be able to have my interpreter like do things like delays and call the network or whatever, right? So I want to be able to do the same thing, because I want my interpreters to kind of have the ability to have to do effects. Damn, you have to look at that. Nice, excellent. If you look at code-free and free as fixed point, you can actually formulate monadic faults. Yeah, that's correct. So it goes, if you want to go further, then it goes further. The rabbit hole goes further, because then you go back to something that Edward Kmet wrote in 2015. And apparently it doesn't necessarily connect. And I didn't first thought that it necessarily connected to that. But more machines, they kind of define the essence of something. They're kind of underneath. Yeah, you're exactly. I'm getting to the recursion schemes. You're gonna. This article is pretty wild. Actually, let me first just paste some of these links for you as well. And yeah, I think that should be enough to get you going. And let me put that one too, because that one is just mind blowing. And so. Okay, so basically, I'll just skip a little bit to the punchline here. So yeah, these more machines, they're kind of, they're part of the machine package of Edward Kmet, but as you might know, the machine package of Edward Kmet is the same as conduits and pipes. It's just more kind of principled and close to mathematics, as what Kmet always does. And so more machines kind of represent this idea of like streams, or but maybe also bidirectional streams, and so close to but formulated in a very different manner than FRP, right? Because FRP, you have all of these other kind of beautiful mathematics behind, like resolution independence and things like that. But all of that seems also like maybe it's connected to UIs. But so he goes to more. He finds a code-free inside the Moore machine. Then he unpacks this by saying, well, actually, code-free really is the application of the fixed data type with just pair, and the composition of the pairing functor and your functor f. So this starts to get pretty abstract, right? You need to kind of hold on a little bit to your seats to you need to be familiar with the notion of functor composition. So we're getting a higher level here. And we use the fixed point constructor directly here. So that's the greatest fixed point. If you're familiar with code-free like that, feel free to be the same, but with either. Yeah, here, exactly. With either, right there. Absolutely. Well, actually, I think maybe it may be actually, right? Actually some, hold on. No, yeah, you're right. Either we return a value or we continue with f. I think you're right. We could check that. That's a good one to check. Free, I think Bartos, free and fixed points. I think in his blog post he talks about this. Free monad, and that's the example, and then applicative. So he gets into the fixed points below. That's a little bit harder to read. That's the that's well, that's the pair. So hold on. Free A, fix H, free FH. Yeah, that's a little bit difficult to read. Yeah, fix compose with pair gives you cofree, and the dual of the pair is either. Yes, yeah. I think you're right. I was just wondering. No, I think you're totally right. Yeah. So here, so he then proceeds on to interpret fix as new, which is a lower representation of fix, where you actually do something that feels a bit like Yoneda-ish, like, or CPS-ish to your fix. But basically, you can define fix in terms of new. Okay. New is the, so he said new represents the greatest fixed point in a much, so it's fix is also the greatest fixed point, but new is also the greatest fixed point, but in a different representation. Yeah, greatest. So he then proceeds on to explain, well, now that we define fix like this, then we can also define cofree like this, and therefore we can also define more like this, and he gets to this more then, okay? And then, like, way later, he then says, well, actually, there's also an adjunction here. And so, and really this talk is, or this article is about representable functors, but I'll skip that because here he defines a representation for more, the more data type that's based on these adjunctions, but basically says, and with F and G being a monad and comonad. And so he says, here our more machine is pairing up some comonad with a function that gives a monadic action that is intimately related to that comonad. And this right there is exactly the co-pairing. And I think he came up with that. Yes, exactly. Representable functor is exactly that. And and their, as I understand it, their practical application in engineering is that it allows you to do memoizing or faster functions because they're memoized, because you're able to store them as a set as opposed to have to compute them every time. And so that's what he's doing here. He's actually trying to make his more machine memoized, because he's going to use it for decoding, decompressing using like an LZIP style algorithm later on. But here the crazy thing is that I think at that point he might have not yet discovered the co and the pairing relationship. So he talks about it as just intimately related to the comonad, but it really is exactly the pairing that I was talking about. It's the same exact pairing. And when you look a little bit at what this is, it's pretty much exactly basically taking, now you have like a free monad and a free comonad, and basically the way that you indeed, like, you make them like iterate over each other in time is a Moore machine. And that makes complete sense, because that's the essence of a Moore machine. It's a thing that basically, you know, if you read the simple type, a Moore machine is something that holds a B, and then you give it an A, and it gives you another Moore machine that has obviously a new B and a way to sort of continue, because it's just waiting for a new A. So that whole thing is just blowing my mind, because I think if you continue on pulling the thread, then you can get to also making it work in a kind of an FRP representation. So that's the stuff that I'm kind of progressively exploring. But, you know, I like to do things kind of concretely, because I'm not a good, you know, I recognize these patterns, but I couldn't come up with them. But I want to use them more and to like build the intuitions that fit my brain the best. And so that, because I feel like if I have those, then I can build more solid software and more ambitious software. So, but then we're starting small here, and the tactical problem, to go back to it. I'll take a look at your hyperfunctions before I get there. Oh yeah, please go ahead. Shoot, I should have asked you if you had any questions before jumping back. Tell me. Isn't more essentially state? So it's hold on. No, because our state isn't recursive, right? State doesn't give you back state. It gives you back a value. So if you have state S A, then I think it's state S, and then such that if you get an A, then you get back an S. You don't get back a state monad, I think. It's bind does? Right. Yeah, I think so. Let's double check. State monad. Yeah, I suppose it doesn't put in the not the easiest way. Right, yeah, that's it. Yeah, an S and a A2S give you back the monad. So I think that's right. The return signature of state. Yeah, I think it's sort of that. Yeah. So, but I think there. But look, in fact, you're not completely far out here, because that's part of some of the intuitions here is that actually this thing, they still pair. Like state actually does pair with store, and free does pair with co-free, and you can make them kind of move forward in sync forward. You can with something that now I'm starting to see as maybe being kind of like a Moore machine, which is really the essence of something that you just give it a bit more fuel so that it advances to the next thing, and it keeps track of where it's at. So yeah, all of that thing is very appealing to my sense of symmetry. Hyperfunctions. I think it's one of the weirdest and most interesting new types you can write in Haskell. So I've looked a bit at hypergraphs, and I think, okay, hyperfunction, slightly more enigmatic, can't monad with a file cooler name. Expanding definition out might make it slightly clearer. Okay, so invoke B2A. Oh, right, so it looks like a cont or a CPS. Right, so actually that's even more an even more stripped version of, it doesn't carry anything. Like more carries something, whereas this, oh, hold on, maybe I'm jumping to conclusions too much. Hyperfunction thing I thought you'd like, since you're very fixed point T. Yeah, right. But fixed point T, like the whole more thing kind of is fixed point T and carries a thing, and then you can still, like, you're still hanging on to a value, so it feels like things are somewhat grounded in the term space, like with mere mortal values. Here it seems like we're blowing up in like the function world, where we continue to want a function to kind of continue on. So wow. Oh, there's a negative and positive business. Yeah, right. Things that, yeah. And they're everywhere. Oh, right. So I would assume indeed that something like that is another way to formulate fixed points, that they might be isomorphic to fixed points. So then obviously then you're going to be able to rewrite everything that iterates with them. Yeah. Makes sense. The category. So I wonder what more, and arrows, nice. So I wonder what more you get than with like a standard fixed point combinator. Maybe like some continuation passing, actually, meaning it's something that that waits for B to get to an A. Wow, cool. I'll take another look at it. It sounds like a really fun pattern. Okay, I'll go back down to doing dumb. I didn't say dumb. I say dumb things. Okay, maybe it's a little bit dumb. Events in the browser. Oh my God, doing functional programming in the browser. No. Yes. All right, sounds good. Hey, Dan, I wish I had a beer. Actually, I ran out. Oh, but I do have a drink. Yeah, I'll have a little drink. Non-alcoholic, but still good to have. Oh yeah. Okay, so synthetic events. How do we analyze this? Call event like prevent default. And why is there no documentation? No, you would ask. So, right, so it's a foreign import. And then the role. You can run detail on the event, and that would get you something. I see. Okay, so there must be a bunch of combinators I missed somewhere, which should allow us to just deconstruct that stuff, like target or key, for instance. There you go. That's the one. Okay, so event is E, and we shall just do key E. Type checks. Nope, and no value key. Yeah, that's right. I just need to import it. It's all good. Synthetic events. We don't need that anymore, do we? No, we don't. Key. Okay. And we don't type check because we have effect string somewhere. Key returns effect string. Oh, cool. No problem. I think maybe. Okay, wrap free. Does this take an effectful thing? It does actually. So we don't need to do pure unit. We can just pass. Actually, let's do this in a slightly more sane manner. You have this terrible take that you miss star syntax in Haskell. Think you love about that style of syntax discoverability or capabilities. Yeah. ID, ID interaction is definitely super good with that. And it's true that with Haskell you don't recover that. You can't recover that really, even with lances and whatnot. Some notion of method. Well, I think the discoverability is really the essence of what's good about that pattern, and also that you have something, because as long as you have some kind of value and that you can sort of see what you can do with it, that's good. So that's why ID feedback is also good, right? Like just having the type give you a sense of what you can do with the results, what you need to put into it. So that gives you some insight. But it's true that the interface for that, the developer experience, it's far from perfect. And that just having like autocomplete with an IDE when you type dot, that it feels like it gets good productivity gains for sure. Oh yeah, of course. Put stir line. Well, hold on. My put stir line here is my own. So. And that's the thing that actually, so that should be fmapped. And then I have a co-console. Okay, hold on. So, I got a co-console unit. Oh, right. I probably don't need to wrap free anymore because that was in the older formulation. So, is that true? Kinda. No, send wants an effect, so it's not happy with this. Okay, so no, I need to backtrack a bit. Wrap free. Okay, let's see. Put the line key E. So that's a effect string. No, it's not actually. Right. Okay, so I need to backtrack a bit more. Let's go back to how it was when it actually type checked. Where we don't know, well, actually, yeah, here we know that at least if we put some actual string here, we know that this type checks, right? Yeah. Okay. So so maybe wrap free. I'm actually not quite sure I understand what this wrap free does. This wrap free seems to be taking an f that's a free. So we basically have a free MA here, and we get an MA. And then send then takes this MA. Well, send actually. Let's go back to send. I think send supposed to it's an A2 effect, A2 effect unit. I think send is a handler A, and it takes any. It's a function which takes any A and returns an effect unit. So am I doing this correctly? I think I am, but is what the dollar greater than independent monadic composition and keep the right reuse it. So something like bind pure const pure 5 and we expect f5. Correct. That's exactly that. I think it's called sometimes void right. I think it's called void right in Purescript, maybe. Let's see. Yeah, void left. Yeah. So it's FA to B to FB. So it's like a const. It takes the F from the left and then squeezes the B and drops the A. And so in this context, I haven't worked out a good intuition yet of what send does. And that's part of something that I kind of want to rework in this framework. I want to extract the UI building side of things into what I would call a driver, which is a similar approach that I quite like from Cycle.js. Where in Cycle.js you have pure data flow and everything, including UI building, is just a driver that's in a side effect. And I really like, again, the symmetry, because in fact, this is, well, this is not exactly a symmetry of an interpreter. And well, no, it is actually. This would be monadic. This would generate monadic actions and monadic action are also expect values, and then all of the side effects will be located in the interpreters. So that's kind of one of the things I'm trying to reproduce here or build towards. Where was I? So isn't rep3 then like a lift? Yeah, I think rep3 is a bit like a lift. Actually, it's like I think it's called eval in like F algebras or something like that. It's like it takes an FA to an A, but rep3 really takes an FMA to an MA. So it's like similar, right? F being a free thing. So it takes free A to A, and I think that's eval in usually when you talk about free stuff. So I suppose first of all, yeah. So first of all, putster line here is pure. It doesn't have any effects. However, when we do pure unit here, I think we are now in effect. So let's double check this by saying val, and then doing something like where val is, I believe, effect unit, and we can have type checker tell us whether we're right or not. And oh no, it does fail to build, so it is not. It's co-console. Hold on. Yeah, the type errors could not match co-console F unit, so it's not. It's co-console F unit. Okay. Is that right? Still not. Oh, sorry, not. It's co-console F unit. Okay. Still not right. Oh, right. Okay. With some kind of M. Oh, so right. So it's effects. I think here is effect unit. So I wasn't quite there. Oopsie. Yeah. Okay. Sort of doesn't type check. So it's not. So it's some M, which I think is a monad. But let's see. Let's make it some fall. Yeah. So there is not gonna know which monad. So I suppose we have to say that it's a monad. Yeah, and so but this pure puts it in the correct monad that's expecting of send, but which one is that? And what did I do? Type variable M is undefined. Okay, yes, that's right. I'm doing this higher ranked, but it's not. And that does build. And so then what M is that? Well, it's the M. I suppose it's the M that's yeah, it's the M imposed by the consumer send, and that send, because it's in this UI monad, is a handler, and the handler is an A to effect unit. So I would expect that it's in effect, but am I missing something? I would have expected there would be in effect. How strange. Let's try it again. See what the error message is. Effect. Huh. Hold on one second. let's get the type of UI, and in fact, let's get all these types in our environment here, because that stuff is hard to remember. So we have a component with a W, which is this co-free co-console F, okay? And then we also have a unit co with this W of unit. And so our W is still here. And so that stuff is there. And so that UI co W of unit is here, and that's the UI, and that's of type UI A with, hold on, that's so A is this now, and so send should be of type handler blah to effect unit. Hold on, so this should work, shouldn't it? Okay, let's check our assumptions with send. Can we do that? Can we do send and RUF type handler blah? And can get handler import handler. And return to this more polymorphic type. Yeah, so that's correct. So send takes this, which is an A, it doesn't care about okay, I need to know what the type of rep free is now. Okay, I feel like I'm being a little bit stupid, but I still can't figure it out. UI A takes a handler A, and the handler A takes an A and returns effect unit. So we don't really care about what he returns. We just want to know that that A is the correct A. Oh, hold on. Is it co-free here? It is. Okay. Holy moly, what? This is crazy. So you're telling me maybe that that this is co-free co-console F unit? No, right? I mean, that sounds preposterous. That would be a little bit too magic for me, but cannot match co-console F with co-free co-console F. Yeah, exactly, right? But then could it be co-free unit? That doesn't make sense, right? I don't think that makes sense. I'm just flailing right now, just trying random things. Right, exactly. Co-free is also is not. This is not properly kinded. So what is this mystery monad? Okay, well, could it be could it be the pairing, the pairing monad? But in that case, it would be what? It would be co-console. Okay. Okay, I'm gonna try something else that's completely crazy. Okay, well, I suppose, hold on. I'm not using all of the features of my programming language here, I believe. I think I can put a type hole. Could not match kind. Yep, correct. I need some parentheses here. And still cannot. Whole hey has inf. Well, I wasn't even dreaming of something that complicated, but that looks like that is exactly the monad. That's the free monad. That's the, yeah, that's the free monad that corresponds to this. Oh, but that's weird. It's super weird. It is really super weird. Is that right? That types check it builds. Oh wow, my what did I do? Exited. Yeah, it does build. Holy moly! Oh my, I don't understand that type at all. But it feels a bit similar to this. I think maybe we need some type synonyms to start making sense of that stuff, because this is a bit unruly. So our monad is co-free, co-console F. And we know that co-free, co-console F is a comonad. And so we know that co-free, co-console F is going to be the associated free monad. However, why is this associated free monad walking around inside co-console F? And what is co-console F compared to co-free co-console F, right? Co-console F, okay, sounds like it's console F, so let's see. Yeah, I think that's right. So we have something like we could define type synonyms like console F, I think is co-console F, such that console, which would be typically in a free monad context, that's how you would define. You would say the console monad is free console F, and so the question is, in fact, is that the same as console equals? Okay, let's hold on to our seats here. Co of the co-console F? What? No, I'm totally lost. Not totally, but close. Okay, let's look back at this. Okay, no, that's not what I should do. I should look again at the definition of co. Totally doesn't help. Co-W is a monad whenever W is a comonad. So that's the important bit, right? Co-W is a monad if W is a comonad, right? That's the bit. So, but co-console F is not. So that's the crazy thing, which is that co-console F is not a comonad. Co-free co-console F is a comonad. So typically, co-free co-console F is a W. And so what I was trying to do was, yeah, the monad, there's another way to get to it. It's co of RW, which is co of co-free co-console F. And so, but there's a kind of there's a square there. There's some commutation. It means that co-free console F would be a monad. Yeah, exactly. We get to the same point. No, you're missing a co. Co-free co-console F is a monad. It's pretty crazy, but that's, I think, what it is. So yeah, co-free co-console F. That's our monad M that we wanted here. And it's a little bit crazy because I think it's also free console F. Hold on. Yeah, it is free console F, but that means what? That means that it's also free co-console F. So I think we have something where free co-console F is the same as co-free co-console F. So we have some kind of permutation there. Actually, isn't that, maybe that's an adjunction? No, like we have a kind of like or maybe that's distributive. FG of a okay. Well, PQ of a M of an F is Q. Oh, well, I know it's not QP, right? It's Q P prime of the same F. So maybe this is a junction-y, I don't know. The circle of chromatic life. Nice one. You totally like fixed point that stuff and call me with your headaches, Wow. Oh, you can even go deeper. Suppose that you have some function F. Hold on. I didn't even read what you said. Suppose you have some function F, then co-free F is a comonad. Yeah, so co-free F is a monad. So no, you can't turn a monad back into a comonad with that trick. That's the part that's asymmetric. Basically, there's something about the fact that comonads are somehow more restricted, which I guess you can get from the intuition that co-free doesn't have that extra exit thing. It doesn't have a tag to get you out. It only recurses infinitely, so it's somehow smaller. Maybe the fact that it is somehow smaller means that it's easier to find the corresponding monad for any comonad, whereas it's not true the other way around. You can have monads which don't have a comonadic pair, or that's not even the correct way to formulate it, is that you can't automatically derive a comonad from a monad. But with co, you can automatically derive a monad from a comonad. Yeah. Co-free is a comonad for any functor. Yes, absolutely, it does. But you're still stuck because once you have your comonad in your circle of life there, you can't get a monad now from that. Oh no, sorry. You have a comonad, you can get your monad, but once you have your monad, then you can't get a new comonad from it. Although, hold on. A monad is a functor. So yeah, you could actually say that, hold on, so how would it work? Console here is a monad, right? But any monad is a functor. Yeah, exactly. So you can't free that. You're right. You're absolutely right. Holy moly. Okay. My brain is bugged. I've been. It's heating up, I think. Right. Yeah. Maybe Ed is in the Discord, not our Discord, but he's been streaming on his Discord. Yeah, holy moly. So I think that okay, so I think to get an intuition from what you're saying, we would need to understand what kind of okay, hold on, let's somehow write it down. You have your co-free F, which is a monad. The question is, and then you put a co-free in front, and then the question is, what is the co-free of a monad as opposed to the co-free as a functor, right? If we have some intuition for what generally, because I have an intuition for what is the co-free of a functor, especially if your functor is kind of like an ADT. Usually, if it's a sum of products, then it's like a, your base functor then defines all the possible things that can be explored. So if you have a sum of, if you have an A and a B, okay, well, the truth is that it matters when, like when you have things like where you pass your, whether you have something like that, right? Like if you have an A, if your carrier for one of your tags in your sum is something that expects a value, then you have a consumer. Whether if you have something where maybe you have an A inside and the next like a product like that, then that's more like a producer or something that maintains its state and then moves forward. And so the co-free of a functor like that, the co-free of f, if f is this, then it means sort of rolling out a series of A's with like B's that carry some value, 1, and then carries then some other B, then carries another value, and then carries an A that then has this function f that you have to run in order to kind of carry on and all of that stuff, right? That's the intuition, is that your functor is a wrapper for each of the step of the recursion, and that defines some sense of traversing, choosing a direction or another for each of the layers. Co-free free, yeah, it exactly doesn't work. So free, okay. So co-free of identity is stream. So that's one thing. Because it's basically, maybe we should have the definition of co-free somewhere here. Co-free is co-free F is co-free of F of co-free F. So co-free identity is just co-free all the way, and that's isomorphic to stream. Is that right? Yeah, right. Because identity is identity A, right? So you're carrying some A. So it's just going to be co-free and 1, and I think that's usually how it's done, right? Something like that. 1, 2, and until the end of time. Free identity is list. Because free is one possibility is to say done or free A, done A, and free F of free A. So either you continue wrapping or you just bail out with done. And so that's actually list because you bail out is nil. So maybe there's no payload there. Bail out nil, whereas this is cons. That's basically the thing, right? So cons of list A, right, would be the way it's at, and so that's cons of free identity A, something like that, right? And so cofree of list A, right? What is that? I don't. Is that? Yeah, it has to be possible, and that it also has to be a comonad. So I think it's the thing where at each step you multiply. You have, you know, a list worth of choices to go forward. So it's like a roast tree, actually. I think that's that. No, hold on. Yeah, no, I think that's right. I think it's a roast tree. Is it? No, it's not a roast tree. Free of list A is a roast tree. Okay, yeah. Free of list A, free of list is a roast tree. So it's a roast tree is something where you have an A and then a list of roast trees, right? So cofree of list is not. Oh no, hold on. Hold on. Yeah. Type rows A, I think, is rows of a list of rows A. So I think right, because list has a nil element that this is how you stop. Like an actual, like an instance of my rows tree will be something like rows. Oh no, it carries an A. Will be rows 1, and then inside it rows 2 and an empty list, and then also rows 3, and then maybe something inside it, and then like a tip is empty list. So that's weird when if you do now cofree of list, then first of all, was that exactly right? Because it sounds more like, I mean, basically if you have an empty list, does this allow you to then stop your cofree somehow? And where is my done here? If this is really isomorphic, then I should have a done as well. So maybe cofree list is actually roast tree, and maybe free list is actually something else. Let's take a look at it. Haskell free list roast tree. Free list. Deriving via free, what was this list? To building most trees. Yeah, roast tries are a special case of co-free lists. So roast trees are co-free list, yeah. You didn't. I love that stuff. It's good to have a beer, and I mean, you have a beer. I wish I had a beer, and talk about that stuff. I love it. And also I'm brushing off and it's since I'm trying to play with these building blocks, it's good if I can spit out the types. It means that I'm at the proper level to actually play with this stuff and try to build bigger things out of them. If I can't, then I probably need to go back to the drawing board and study it a bit more before I can build bigger things. Kofi has posted tag. No, that's the reverse. Well, yeah, okay. Well, no, it's not a tag per se. It's the functor layer, and then maybe your functor carries a tag. So yeah, that's kind of how. But it's the functor that's the tagging. Whereas free, you could say it has the functor layering plus an external thing to bail out. So free of list is a kind of so if co-free of list is a roast tree, then free of list is just a slightly different beast that's a bit weird. It's kind of a roast tree where you can have different, where you can have a dawn inside a roast tree, right? So it becomes isomorphic to that. So feels like a bit of a wasteful roast tree that maybe like some kind of exception in it. I don't know, like you have some special element that maybe it's Waldo. So you have a regular, it's like my Waldo roast tree, right, where you have rows and 1 and then rows 2 and then empty thing, and then no Waldo, and then at some point Waldo is here, and you're like, okay, what is that? Is that a roast tree? It's not really. It's just Waldo. It's just hanging out there. Okay, you needed to just have like some kind of special thing inside your roast tree. I don't know how useful that is. So then the question is, okay, so now you have so co-free of free. So if free identity is a list, then co-free, we have some answer to your original question, which is at least that co-free of identity is a roast tree, right? So we know what co-free of free is for identity. We don't know for any general functor. We sure as hell don't know for a monad, because then, so here's, okay, now that we built that up a bit though, right? When f is as simple as a functor, especially as simple as a kind of an ADT style functor, like that guy, or like my console type, like some of my original console type here. With a constructor and an either and like sum and whatever, then it's fairly easy to think about what layering these things mean. It's just you choose one or the other, and one can carry some stuff, one can be like expecting some stuff, and that defines the whole behavior. And it's pretty magical that if you do the free of any such thing, then that's a monad. The way that I think about that is just that a monad usually is kind of a set of recipes, right? Or a set of actions. That's usually how we use a monad, or we program with a monad, like in the IO monad, for instance, in Haskell. It's a suite of actions which include the capability of getting some result from the previous action and choosing what you're going to do next based on that. So this intuition works because our functors have a next slot. So it's and that's what makes them not necessarily regular ADTs, is the fact usually that thing is called A, by the way, but I like to call it next because it definitely highlights its use in a free monad context, which is that It just is the slot for the next action. And so if in addition to the slot to the next action you carry a value, then clearly your next action can get that can use that value, like in this case, can use that value to decide what is going to happen next, which is exactly the power that a monad gives, which is, for instance, something that an applicative doesn't give you. An applicative doesn't give you the power to choose what you're going to do based on what was written in the previous line. Free of ID should be an indexed choice of some A. Free is free FA is A of sum of F free FA. No, I don't think so. I think free of identity is list in this way. So if what you call an index A is a list, I suppose you could see a list as some, but it's not the A, like, I don't know if your capital A is the same as your little a in here, but it's hard to, I mean, can you think of a list that is an indexed A? I don't know. Indexed by A? Not even, right? It's indexed by naturals. This is actually, also 0 and Z in the piano number construction, right? It's like if you do, how is it called? I forget the term. Like it's linked to recursion, but when you use that to define your data type, I forget. Yeah, definition of free is right here. It's either done or something that looks exactly like co-free. So either you bail out or you have or you do the layering thing, but you have this, as opposed to co-free, you don't have that possibility to bail out, which is why, co-free of identity is infinite streams, whereas free of identity is lists, meaning finite streams, if you'd like, right? Because you can bail out with done, which is exactly what you can do with nil. And if you look at the, the type of lists, right? It's list A is nil, or you continue, right? You continue with const an A to a list A until you're done. And what is stream A? Stream A is just stream of an A and stream A. So you can't bail out. You just have to continue all the time. With the list, you can bail out with nil, and then you're done. And that's exactly the difference between free and co-free here. Free is done, free F, free A. Co-free is co-free F, co-free F, co-free A. Or, yeah, F. Yeah, am I forgetting something with the done? Is that not right? Haskell free. Monad free. Yeah, those type definitions don't necessarily help out. Also, because most of them are also built in the source code in a more complicated fashion, because they use the transformer. So it's let's see, we can find this elsewhere. Free structure. Oh, yeah, data free F. Data free F. There we go. All right, so it does have an A in it, but yeah, I wasn't sure whether it had an A in it. It has an A in it. Yeah, the Boolean carries an A, exactly. Which is useful, but that's the pure for monad. So it means that, or sorry, return for monad. Like return actually carries an A. It's a way to get from an MA to an A. So you plug identity to free. Yeah, good point. Hold on, how does this work? Okay, let's take this definition. Let's call it done, and let's call it free. Although it's true that it's a little bit confusing to have free here and free here, right? But so yeah, maybe roll is interesting. And then let's try and roll it out. So data, I'm going to make a free list of A. Let's even do free list of int, right? Then it will be a done int, and then roll list of that's the functor, and then free int, or so that's where the recursion occurs. So so yeah, for some reason your done would carry some int. Oh, so it's non-empty list. You're right. It's non-empty list. Yes, you can't get empty list. Yeah, sorry, you're totally right. Oh, an index choice. Huh. Yeah. Yeah, it's non-empty list. You're absolutely right. Haskell free identity non-empty list. Huh, these results are spectacularly bad for the type of learning we're trying to do. How would you extract multiple A from a free identity A? You have to, it's like a lazy list in Haskell. You have to consume the data. No, you can't get them all. You just you have to deconstruct them until you get the done. So you basically we can do that. We can even code it, I think. Let's have fun with that. So my list, let's say that it's actually of type free identity int. So I'll create one by, so the simple one is well, I think here. Okay, well, we'll create a free prime that has this type, free prime, and so it's going to be done. Actually, I think it's free identity I. Yeah. So if it's done one, then I can. Do I have a main here? I do have a main. So I think, how could I print it? I could print it maybe somewhat in here, very arbitrarily. I will show my list, and then it will build, and then we'll be able to see a node type free. That's fine because it's free prime. Still a node type free, that's because it's a free prime here. Hey Jill, thanks for waiting. Super cool. Nice to see you again. We're having fun with building up our understanding and intuition around free monads. I was doing more work on the comonadic QI stuff, and Graph stopped by and asked me a bunch of cool questions, and that was a great way for me to flex my muscles, memory, and about doing free and co-free sort of a little bit from the ground up. So it's cool. Yeah. So let's see, is this working? What am I missing here? Could not my string with React element. Yes, that's right. That's because I haven't parenthesized this correctly. And we'll put a apply here. And then we'll miss a show instance for my list. And I think can we derive that? Probably not. Can we derive this in Purescript? Okay, I need to show off. Graph, you're a Hascaler and a Scala guy, right? So lift it so much you can lift your P muscles. Yeah, you lift all the way. Hey, yeah, Purescript getting easiest. Hey, Muzenkab. What is this? This is me going off a tangent because it's Friday. It's not Friday, but tomorrow is actually is a holiday for me. So Graph's having a beer. I'm actually having a kombucha, but if I had a beer, I would totally be having a beer. And I was explaining why I love comonadic QIs and talking about the free co-free stuff, and we'll pop back the stack. I go back to what we were talking about exactly, but that became a little revisiting of what is free and co-free and how can we play with it, what is free of identity exactly, and what is co-free of list, for instance, and this kind of sort of well-known results, but that are always nice to look at because they're so pretty. Graph, if F has a show, you think should have a show. Well, yeah, but in Haskell you could do deriving show. Here, I think I need to first do. Okay, I don't even remember how we derive stuff in Purescript. So okay, so we can't derive show for free prime just like this, even if we say something like oh yeah, no, that needs to be show free prime. I think that doesn't work. What does it say? It says, yeah, you can't derive show automatically. Even if we say with F being, actually I'm going to have trouble to do that because of the fact that this is a higher kinded type, free prime, right? It takes F, which is star to star or type to type, and a type. So I'm going to have trouble. I don't know how to derive show from that. You don't think you need show? My work moment is going to be over if you can instantiate a free identity in that host 2 int. Oh yeah, sure. Here, have it. Role identity and oh. Right, 2 ints. Yeah, what the? Oh. What? So free F is not non-empty lists? Yes. Okay, I am totally borked as well. You can't put a 2 in there. That's not right. Holy moly, you have to do done 2. Okay, so free of identity is not? Right, it's just natural numbers. Is that right? An index, right, it's just natural numbers with like some arbitrary payload in there. Right, so that's like 0, and then this is like suck. Yeah, it's not. Yeah, you're right. So, okay, so free identity is not list, it's not. You're right, so it's free either, or free maybe. Free maybe is list. Yes, that's the thing. Free maybe is list. Yes, because we can then obviously do. No, we can't. Hold on. What? Free maybe. Just no. It's still not. Free over tuple is list. F being so free of tupling with int or something. Non-empty list. Yeah, I think that makes sense. Although we have 2 types now, right? Or is that the same? Yeah, I think it's probably the same type. Okay. Well, clearly I have some more work to do to build up my correct intuition on free and non-free, but maybe we should pop back the stack a bit for especially if you guys are interested in what I was doing before I got into trying to see how I apparently don't know so well free and co-free as I thought. Yeah, the reason why we got into this is because we got into, okay, I need to backtrack a bit, right? The context is comonadic QIs. And yes, so comonadic QIs are, I'm particularly interested in a particular type of comonadic QIs. So let's see, right. Comonadic QIs I find are best represented with this slide, in my view. That's the essence of it. It's the fact that comonadic QIs is basically the insight that different types of UI frameworks are an instance of a different type of pairing of a monad and a comonad. And that this sufficiently describes like these very different UI frameworks. And I'm particularly interested in this particular pairing, free and co-free, because it helps me understand the other pairing fairly well. Because the way that I understand it is that a free monad that's built up from a functor f usually will have a shape that's a little bit like this. You define like something like console f of an A, and I call this A next, and then you have like in this case, for instance, a sum of a put_line constructor and a getLine constructor. And so the put_line constructor carries a tuple of a string and that next, and the getLine constructor then actually waits for a string to come in, and then it will output a next. And when you build free of console f, what you get is a monad in which you have these 2 actions. And it really looks like a monad because you can do actions that don't return anything, like put_line. You just pass it a string, and then it will just do some side effects somewhere. And then you can also do side effects that expect something before they can proceed, which is very much the essence of a monad, is that a monad can wait, so to speak, right? It can decide where it goes next based on what has happened before. And that getLine here represents that. It will go forward based on the string that it received, and then it will move forward. And the intuition and the relationship with the with the free type that we were looking at earlier, which is let me try and find it in this list. Yeah, that one is the intuition is that you're either done and you return something, or you keep wrapping with this kind of role constructor. You keep wrapping your functor f around the next thing that's going to happen. And so it's basically a chain of this constructor. Either you do like a lot of put string, and then once in a while you get a line, and then you get from getting a line you get a string, and then you use that string, and maybe then you put some more lines. And so that will represent like a monadic computation, a monadic value, like a bunch of things where you print out to the console and you wait for the user to input some stuff from the console. And wrapping this base functor in a free monad is sufficient, in the free constructor is sufficient to give you a bona fide monad. So that's the intuition here. And but what comes with the paper from Phil Freeman about comonads as spaces is this idea that in this pairing, when you pair a free monad with a co-free comonad, then they kind of click together in a way that's really important, which is that the free monad becomes the thing that defines where you go, and the comonad defines where the state in which you're moving. So and then the thing that's really cool that you get sort of for free, sorry for the pun, is that actually any comonad can automatically have a monad generated from it, and it just happens that it will pair with it. And so so you only need to write the co-free side of things, and then you get all of the free side of things for free. And if you do that in the UI framework, then it starts looking like what I have here as an example, which is that you only write the base functor for your comonad, which has here which is a record, so a product type, as opposed to a sum type here for the base functor for the free monad. And you define the put case and the get case, and then by putting co in front of that data type, you can get the same monadic value that you would get from a free monad. So yeah, I see that most of the folks dropped out. So so we can just continue where we left off, which was just a tiny bit more pedestrian, but it was pedestrian, but not so much, right? Basically, we realized that in the Purescript React Explorer library, which is Phil Freeman's original formulation of this comonadic UI stuff, we were looking more deeply at the type of sand and how you use these monadic value in his framework. And then we came up, like, there was some type errors, and then we found that the value that we passed to this wrap free combinator that Phil wrote is of this weird type. And that led us into this interesting exploration of the cyclic nature of the relationship of free and co-free. So let's see. So what we know is that that unwrap, or that wrap free, had this type, and I think we should copy this type to have it around. I want to understand this well. So this monad free here is not exactly the right kind for just being free, right? Because it has an M in it. Is that the monad? Is that free T? Monad free here? I wonder. Oh, mass battery. Okay, let me fix that. And drink a bit. Okay. So of course, one question here that arises is, could we put this wrap free maybe in here so that we don't have to put it here and that our code is slightly more monadic somehow? And then where I was heading is also, how do we make put stir line here effectful? And where does that effect live? So, okay, so pure unit here implies that this put stir line A, the type of put stir line A is co-console unit. Co-console F unit. So that's clearly not the right type, and apparently with unwrap free we would like to have this in this monad instead. Do we really need that? I'm now wondering. I need to go back to the original code from Purescript Direct Explorer. And that was in the tests. And maybe we've changed something in such a way that maybe this is just a remain and that we don't need it. So here, move right was the monadic action that Phil defined in his examples, and he was using it in this fashion with wrap free. And the interpreter was actually inlined right there. So I've packaged it into a function and I have it up there. So we were using wrap free. The fact is that send seems to be waiting for, oh right, the type of send is a handler of that thing, co-free co-console F. So it's true that we need to go from a co-console F of unit, co-console F of unit of unit, which is what put stir line A is, to a co-free co-console F unit. And that's what this wrap free does in this way. Which is that, why is it this way? I'm not exactly sure, but probably we want to understand that. Let's see whether wrap free has any documentation that's useful for us. Let's go to Purescript. And go to wrap free. And that's from monad free. Huh. So that stuff is really specific to monad free. But yeah, just a little bit of context here also is that this used, I think, an older version of the free package, maybe, because this paper, this whole shenanigans were done in 2016. So I think, I'm not sure whether this monad free is used so much these days, but I might be wrong. Let's look at So monad free would be what? It would be the type class version of, I would expect just a free monad, but here it has an M. And that I don't understand. So let's look at the Haskell version then. Monad free. Have a wrap. Wrap at the layer. That doesn't look like adding a layer. That looks like removing a layer. Mm-hmm. Okay, let's not look at the transformer version. It's going to be confusing. Okay, we know what monads provide. List is not a free monad. That's fine. On the other hand, yes, a binary tree is, and it's the free monad of pair, and you can make an instance of monad free. Oh. Okay, hold on. How does this work? So this sort of declares I don't understand this pattern, but I think I've seen it quite a bit. It transforms what you would usually use as a type into a type class. So how does this work here? You make an instance of monad free for pair tree. So okay, let's write this. Well, it's all written here really. So data tree, instance monad tree. So you have a tree constructor, and you're somewhat saying here that there's an equivalence between your pair base functor and the tree data type. A tree being seen as a monad then, but the tree monad? What is even the tree monad? And so in this case, it would go from a pair with a tree in it to a tree. So that sounds like unwrapping. This is all completely confusing me. And this doesn't help, right? Like, this is also wrap, but in this direction. Okay, and then there's an instance of f and free f. So I suppose that that's I suppose that is kind of create that's probably what we're using. That's probably the instance we're using, is it? I imagine maybe there is an instance for monad free for co. We might want to check that. That would be in the Purescript pairing, not the React Explorer. Let's close a few things. React Explorer, that's free, and pairing, and then monad free. Yeah, that's right. So we're probably using this instance that says that given a co, right, yeah, that's exactly the instance we're using. It says that, and that's the, boy, this is mind-bending. Giving the co of a f, we get its free functor via the co of a w such that the w is the comonad of the f. Yeah. And so I suppose that where the reason why it matters is that writing this instance gives you this, apart from, I suppose, higher symmetries in the understanding of how this whole thing works. But this is stretching my understanding right there. Okay, I see how it mechanically ties to one another, but I don't understand why it's needed here. Although it seems like that it's related to the pairing. For sure, it's related to the pairing. But I thought it was possible to do the running of the pairing in a way that would be fairly decoupled from the instance of use. And I think that it could be that there is a better formulation where you are able to pull that off. And maybe that's one of the things that actually Arthur Xavier in his later formulation was able to do. So I'm not going to be streaming for so long, but I want to note some of these next areas of exploration. And maybe I'll try to hook it onto AF as well, like quickly. But at least next, what I want to understand is look at how Arthur Xavier does wrap free and the monad free co, oh yeah, the monad free co f co g trick. And now make a note of this. Because yeah, I think this had been improved in the later version of the library, even though there was some stuff that I couldn't understand. It seems like in the new version of the library, maybe there were a few things that were lost and a few things that were made more complex. So that's why I reverted to Purescript React Explorer a couple of streams ago. Okay, so fine. I think that will help to sort of maybe make this whole thing a little bit more intuitive. Maybe somehow making the, yeah, I'm not sure exactly how, but I feel like I'm going to need to have to understand this if I want to, especially if I want to move the rendering code into a driver. Okay, so let's see. what else do we have? Val. Okay, so here we're doing the wrapping, which is really an unwrapping. Oh, I see why actually you can make it, why you would think that it's a wrapping. Because you put an F around it and then it gives you the free monad that comes out of it. So you're adding a monadic step. Huh. So that kind of presumes that you're passing it a monadic value that maybe you've been stringing through the program, but here we're not. We're passing unit. So I think that means that we haven't tied the knot. Our input is not connected to our output currently, because I think the example that we derived this from was too simple to need to do that. So that's another reason why we'll want to connect to the later formulation by Arthur Xavier about this whole thing, because I think he definitely did consider that stuff. Okay, and then what? Yeah, because this looks like we're wrapping around pure unit. And I'm not sure if that makes sense. Okay. But then this somehow gets passed to our interpreter, which I'm going to put back here. And right now it's in string, and what I would like is to put it in f string, because that would allow me to input to do something like console log. Actually, yeah, log, for instance. Identity, right? So str and log str, for instance. So, all right, but then I need to lift effect, and I need to import f, which I don't know if I actually installed. I might not have. Let's see. I think it's just spago install f, isn't it? And then here, will you find f in the list of potential imports here? No, but maybe because I need to spago build. Yes, and except that we don't have my list here. And there we go, effect.f. And then lift effects is also from that library. It's actually from effect.class. Do I need that then? Don't remember. I think so. And then log from effect console. Okay, and then this needs to be returning a, let's say, a pure fake, I think. All right. My string with units. Okay, hold on. What am I doing? Tuple string of for string T0. Hold on, what should be here then? Let's back a build. Nothing special should be here. Console f string should mean that we have an f string here. What? Where is the unit? Is it that the error message is not in the right place? That it's actually up there that we have a problem? Or is it that to create a value in f I need to do, actually I need to wrap it? I forget how this works. But here, what's the problem? String with unit. Okay, that's really strange. Does it want me to have a unit here? I do not understand that. Okay. No, so it wants me to have a unit here. T0 unit. So pure unit then. But that still doesn't match. Ah, okay. Oh, okay. Yes, got it. This needs to return the string. And now I can have some string. Yeah. And then I suppose we are in console f string here now. And then we're in trouble because because the component is in effect, I think. Because r.react elements, I think this all lives in effect. And send. No, that's another send. But even the fact that our handler lives in effect unit, so maybe we should be a little bit less ambitious and start with effect, because I think we're going to have trouble upgrading this to f. So let's just do effect for now. And with log in any case, that should be sufficient. Okay, so we still don't match, but this time well, this time in fact I think we can return console string. Top of the UI. Yeah, so clearly we need fx string here. But then build co-free doesn't work, but probably Build code-free takes the step. And the step is an S to a AA FS and an S. And returns a code-free FA. Oh wow, that type is a little bit ugly, huh? So good that it expands it though. Takes an S, which is our state, really, right? Yeah, we could keep the interpreter pure and have an effectful like interpreter wedged in the send hook. That would be a way that we could get around this particular architecture until we find out how we kind of make it more regular by moving some of the parts in other maybe outwards somehow, which might mean also moving the rendering aspects into some kind of lower layer rather than so getting rid of the component type and making this look more like Cycle.js basically. I mean, the send is in effect, and so we do have a lot of latitude there, and it could be that we need to make to somehow couple better the send and the interpreter. Like maybe I suppose the way this is separated, the step is supposed to be pure, and then, however, send can use some of the result of that pure computation to do something effectful with it. Now I'm talking about pushing the interpreter down into the place where it could be itself effectful. I'm not sure whether that's so elegant. or easy to understand. A lot hinges on this build co-free and on the explore. Where is it? It's in explore here. Explore is one of the workhorses. The pattern of decoupling the UI, making the UI function from state to some UI is somewhat obscured. And because the pairing kind of falls in between some sense. The UI part and the state part. So the explorer takes the co-free comonad with the effects and then deals with all of that stuff. And co-free builds one such co-free comonad, and build co-free, make sure that's done by having the initial state, by doing the recursive scheme. Right, so you could say that the build co-free, the step is what builds each layer of the co-free comonad, and that within the building of that layer of the co-free comonad, it needs to do the building of a layer of the free monad. That's its co. Yeah, so it makes me wonder whether there's a way to expose more of the kind of the more machine iterative aspects there. But it could be that this entangling is also linked to the UI and the effectful aspect, that the way that React also itself deals with state and effectful stuff. Yeah, lots of moving parts. I'm definitely not there. So So if build code3 takes this tuple of an A and an FS, that the A is the UI stuff, and the FS well, the FS is actually a the code3, the base functor for the code3 comonad, and the next state. Yeah, so it's really this where this build code3 is positioned. I don't think we need maybe we need a build code3 T so that we can wedge in an M and then interpret it at each and then execute the effect of a base monad at each step. Is there a build code3 T? There isn't. Yeah, I think when I looked at code3 T, it was missing in the department of running things. Basically, I think interpret code3 T is the way to go. Yeah. And even that, I think maybe like there's the co-iter. Yeah, I think actually that's something that Arthur Xavier came up with then. Let's say comonadic to-dos. No, so I must be confusing my frameworks here. I think co-iter is definitely somewhere, but not here. Did you have something to run? Yeah, unfold code3 T. I think that's something that the regular code3 T doesn't have, which takes an S and returns an S wrapped in a W with a tuple of A and FS. So yeah, that's exactly what build code3 is, but well, build code3 I think is unfold code3 basically. Yeah, that's unfold code3. S to tuple A FS and S and code3 FA. Yeah, so it's the same. But it's a comonad transformer. It's not a monad transformer. So it's not exactly that. The wrapping W here, that's not what we want. That's going to build some kind of comonadic transformer stack, which obviously is what code3 T gives you. So it's a bit more subtle than that. Again, where your effects are going to occur. So I think that relates to how you're pairing your stuff. So my mind keeps getting back to that more article. but I'm not even sure. Yeah, still not sure how that would even work. Okay, co-resume. Yeah, no, that's still not it. Okay, what? Let's look again at what the explore stuff looks like here. To React, explore. UI.explore. I think we need UI.explore. Extracts. Pairing is a tag class now. Yeah, I kind of like this when I saw it first. Handler. Yeah, well, first of all, it has the base monad. So that's obviously why you have a component T instead of a component, and that allows you to wrap effects. And that's with a base is actually a monad here. And that changes things quite a bit. You do have to carry that around, but yeah, it means you can return in base, so you have a choice of. So we definitely want to incrementally add this. Maybe not all of the complexity that arises, but at least the base. Yes. Then that M. Yeah, that's actions of type M unit. Okay, hold on. Let's take a look at this. That's a huge difference. The fact that now the M is explicit as opposed to being calculated derived from co. And I don't think we need that M. I think that looks like an error, like a misunderstanding of the role of co. And it's really strange that that hasn't been picked up. I don't understand. So M, we can definitely get rid of it. A, here it's been pinned as unit, but it's not the same A here, and not sure it's needed. So we just have base, we just add base. Okay, let's try. Yeah, it is tempting to call it M, but I see how that could be confusing. So let's call it base. And then we add base to UI. And then we add it here. Then we add it to handler. Hey, that is also quite different. And the base here, that's important. It becomes base of A. And okay, action, sure. I kind of like that. And base of units. Okay. And now let we follow the types. So here we need a, okay, so and then explore here. What is it? What does it do with, oops, sorry, with monad base? Changes the type of the handler. We call it V. Type variable undefined. So here also there's a decoupling. Yeah, there's a way to allow execution of melodic action in the base monad. So this is all good. I want this. So we will call this explore, and we will create a React folder and put in it a UI purse and do the same split here, because I do like that split. It was UI React, but I think it makes more sense as React UI. I suppose we could also just have a React. This is in fact all in source React. So maybe it's a UI folder. Maybe it's a UI. Maybe we move UI in here. And we delete React. That seems like maybe more clean. And then we copy UI React. And so that also has an Explorer. I don't quite like that, but that's fine. Pairing. We don't have an M. React components don't have an M. However, what is a React UI though? A React UI is a UI with action handler running the effect monad. Not sure where that's used actually. A React component is a command that is describing a space of all possible React UIs. Yeah, okay, yeah, we don't have that, and we don't have the React element because that's fixed, and that's not UI, that's React Explorer. Explore. And so that's Explore UI. So that's the more abstract UI type. And therefore, I think we can in fact now just copy all this, which is pretty bold, but let's just keep this and then follow the type errors. I don't mind keeping the pairing, but no, we don't need the pairing because we automatically derive our M, and we don't have an A, and we don't have an N and an A, and we don't have an N and an A. Are we supposed to return an A? Yeah, that's, I suppose, just a tiny bit unfortunate, but it means that there's really, yeah, I don't know. Let's just do it like this. It's fine. Component T. Yeah, component T. Right, component T we haven't defined. Component T exists, and it's this guy, and it doesn't have. Right. In fact, component is just component T with yeah, component W is component T identity W, right? And component T base W is W wrapping UI base and then co w unit, and we don't pass the a. So that's the correct thing. Okay. And we need to import data functor identity or data identity. Okay. And then we continue down, and monad trans. Yeah, we probably need that. So let's get it. Monad trans from which monad trans? Oh, from this. Okay. Did I have this? Did I have this in the list? Class, no, it didn't show up. Okay, well, it's all good. We get it. And what's the deal with move? Okay, we don't have a value move. Why not? Right, because what? No, why not? Explore equals right space blah move. Okay, we're importing move from control command pairing, which we don't have here. We have data functor pairing, so we'll just import that. But we need to make it compatible with this, and that's, I remember looking into this the other time, and it wasn't super straightforward. Oh, I'm funny, I have the Commodic UI stuff right here. But okay, control command pairing, that's the move. And it takes a pairing. Yeah, we need to rewrite those for we need to rewrite those in terms of well, yeah, the pairing which is imported from a library. So you know what, for now we shall add them directly here and in explore right there. There's no move. Move shall be defined here. So how do we define it? Well, we're not interested in any pairing. The monad that we're interested in here is the co of W. And that means that we have a pair co for that, isn't that right? So just need to import it, right? Is it not pair co, or is it pure? I should have the pairings imported, because this is a little bit not the easiest. Pairings, where are you? You are here. And yeah, you have a pair co, right? No, you don't have a pair co. You have a run co. Okay, where was pair? Let's go check out where was pair. Pair should be in in a more recent version of data functor pairing is the problem. Oh no, there is a pair co here. So that's data functor pairing co, as opposed to data functor pairing, which doesn't have pair. Because it comes from here. Okay. Confusion. Data functor pairing and pair. And the type class pair. Yeah. So that's ABC, FAGBT. Right, it's pairing FNG with a function that shows how to pair. And in the co-formulation, we have pair co. And I think, okay, well, COW is a co-W. Hold on, it's supposed to take a W. What is? Oh, okay, yeah, this is the bow tie thing. Which is the pairing. In this style. Where is it not imported? Ah, right, it's imported right here. Okay, so I should look at the bow tie instance in data functor pairing, the old version. Yeah, it's just pairing is that same thing. So yeah, bow tie is the exact equivalent. So reverting back to where we were, holy moly, this is a lot of mental juggling. So we did have pair here. Yeah, I think we replace it by pairco. I think that was correct. And so we just need to import pairco here. Yep. And yeah, right. So duplicate, yeah, okay. So we just need to import the duplicate from comonad. It does type check, and then up there we do the, well, we'll see whether we need to do the same trick. We were just trying to do move for now and see whether move actually makes explorer type check now, and it does. And then go to the next error here, and then we see that, yeah, indeed, we don't have pairings. We have a co W here. We don't have an A, and we don't have an A or an M. Cassia compiles, and no pairing, no MA. Co W. Oh, okay, so maybe the F. Pairco takes the F, which is const identity. Oh, the M. Okay, yeah, it's reversed. And yeah, in this old world, we no, I don't know. Hold on, what is it? Is it that we don't pair with const identity? Or is it the unit is wrong? What is it? Okay, let's go back here. The send handler, maybe the type needs to be changed here. Yeah, it does. But it's not the problem. Takes a WA, code W of unit, and pairs duplicate of W. I don't know why the duplicate rather than W, but and then M. W pairs with code W whenever W is a functor. Okay, well, so hold on. In that case, maybe this isn't right. Yeah, no, that doesn't work. That's for sure doesn't work. So apparently our WA which is duplicate W, maybe it's this unit here. Don't they need to be all? This is a little bit of a strange type. You're saying that your monadic action needs to be in unit here. And this is kind of the, yeah, I like this formulation. Like the move, I think, is pretty close. It's the right way to look at the interaction of one layer of the monad with one layer of the comonad, I think, more or less. But so it's kind of saying the yeah, I am starting to see that this might not solve our problem, the one of introducing an effect, because even though we have a base monad now, the fact that move doesn't occur in this base monad, that's going to still mean that we're constrained how we write our interpreter, I think. So let's try to still make the type aligned with this, because they're still going to allow us to, for instance, run the handlers in AF, which is always a gain. But then I think we'll need to go further forward in order to have effectful interpreters. Okay, but it still doesn't work right now. So WA. So should this be an A? Is that a thing? No, it should be WA. So Perco. Yeah, right. Yeah, Perco gives us a code W, but the type of yeah, it returns a C. Not a WA. So how did that work? How can that return? In pairing, here with pair, this returns a WA. Oh, because of the duplicate, I suppose. Yeah, the duplicate means that then the return value is a WA. Except that we need to, except that W, I think in our case, is the base functor. I don't know. So hold on. Explore. Move text to WA. Perco takes. So to be honest, I need to make this more explicit here. This is Perco, and then this is pairing. And then this means that Perco really is pairing W COW, and that means that that's really for ABC, ABC blah. WA COWB to C. And that's kind of what we wanted, because our pairing here, or our pair, is exactly that. Or is it? For ABC, ABC, FA, GBC. So when we did pair, well, the original move and did flip things. to continue looking into that flip thing. W is a comonad, and we, yeah, no, yeah, no, yeah, no. Passing the M as the F. Okay, has this really been switched all the way in here? Pairing M, W, and here W, M. Yeah, so the monad is first. Is that right? Is the monad first? Pairing M, W, so the monad is first and the comonad is second. So yeah, it is flipped compared to where we are now, to our stuff. Our stuff has the monad here. This is the co of W is the monad. This is the comonad. So yeah, so it is flipped. Type-wise, this matches, except that why would, yeah, the result of the WA, oh, but then const identity is not the same thing. Haha, that's what it is. Yes, because const identity is going to be it's going to be A to B, and it's going to ignore A. Okay, let's see. Const identity equals what? Const takes a function and an X. Right, an A and a B, and returns f of B. So our f is identity, so this is returning B, right? Is it? I think so. And so we want to flip that. Well, actually, is that really all? Do we just want to flip that? Yeah. Okay, there's a kind thing going on here. Where first of all, there's a typo here, and then UI base action, UI base MA. Yeah. Okay. Well, how was this before? Oh no, that was action P actually. It's not a typo. So what's up? UI. Oh, base action A. Okay, right. We don't have an A anymore, so we don't have a natural transformation. I don't know how key this natural transformation is. It might be important. Natural transformation of child UIs into parent UIs. Even a way of transforming effectful action of the child into effectful action of the parent. It is quite important. Damn it. So we need to keep that A, and we need to at least that A, right? Yeah, we can fix it in some of the parent stuff. We seem to be needing to keep that one. suppose that's okay. We shouldn't have UI stuff pop up. We should mostly be using components, but yeah, I think we're going to need that. Although I'm not sure about how yeah, effects are composed and whatnot, but to me it makes sense if we are able to define effects at the children level and then we compose effect for components, then we need to have some order of execution that's defined in the parent. Okay. Maybe this will change if we do more Cycle.js architecture, but unfortunately we are going to have to add back an A here. And that means we are going to have to say that this is an r.react. That's what this was, right? R.react element, yes. And there you go. But it shouldn't leak more than this. And then, however, we're going to have to rewrite a few UI dependent things. Oh, that's all good though. And yeah, we just need to do action P. Very good. And then component T, that's also natural transformation. So component T needs its A as well, I'm afraid. So I guess we have to continue pushing things down. Hopefully we won't have to do this for component, but shall see. Component T base WM. Yeah, there's no W, there's no M. That's fine. And then so MP. Oh. Maybe that's why the co stuff disappeared here. Because how do you speak of a monad transformer on the monad without mentioning the monad itself? You have to do some type level trickery, I think, is the answer to that. Okay, so let's just hope that we won't need that right now, and let's keep it for later. And same for this. And then what's up? Well, same for this. And then what else? Yeah, and then we're missing. Well, in that case, maybe we're back to getting rid of our A here and fixing the React component, because there's really no reason to add this. And yeah, we just need to remove the A here, and then this natural transformation is not going to work. But let's say we also not care for now. Then UI base action, that's right, but what was this natural transformation as well? It is. Okay, fine. So we don't do any of the lifting, but there wasn't any of the lifting in the original formulation. So fine, we stay close to the original formulation. Here, however, action. That might be because of the swapping of things. But let's see. So this should be a co-W unit. And then we don't have an A or an M. And then type checks. Woohoo. Okay. And then what's up here? We don't have a pairing class, so we don't do this. And then component T doesn't take the React element. And it's explore. And React component doesn't take an M. And React UI, okay, hold on. It's an M and has that M in there. So we don't need an M in React UI, but yeah, that's going to be a bit tricky. I don't know where that's used. And yeah, we still need to pass something in there, which is UI effect, UI effect M, UI effect M. Okay, so there is an M here for us. So action, I think we call it. No, let's not call it M. And M is ambiguous. Type checks. And so now we have to use the well, actually, we can just use that main, can't we? I think I was trying to plug in. Yeah, we'll have trouble exactly matching how we plug in that code, for example. Remember trying from this direction on last time. But I think the main thing is we do right, to React code, for example. I think that's the main thing. With to React coming from UI React. So in our case, from just UI to React, yes. So it's not explore anymore. It's not unsafe create leaf element. I think it's just to React together. And this comes indeed from UI React. And it type checks. Holy moly. Okay, let's double check because I think I have some stuff lying around. That's not right. Okay, React Explore Sum is not right. React Explore Day is not right. That's fine. I think we can can we fix that actually? Component still takes only a W. But UI takes more than a W. It takes a base and an action now. So can we make this polymorphic enough that we can say, well, yeah, it takes a base, it's fine for all B. Maybe deal with co. Really type of kind of code, you know, right? That is strange. No, it's kind of UI, right? This is the base. Although, yeah, the kind of code is a bit weird. But I think it's really here. So we're saying what for all B, UIB. Yeah, maybe. And then what? And then our left has a problem. And we're taking the render functions of each of the components and sending them elsewhere, but why would our render functions be different? I don't know, but I think we can maybe ignore that up to a certain point, but we're going to have to trim the example of the day and some examples, and that might actually break some other stuff. Our main specifically, because now, yeah, now we're not going to do together. Okay, because it has combinations. We're just going to do well. Really, we just we're going to put go for example here. And then React Explore list is trying to explore. Okay, so that's all good. Expected. Another vehicle, for example, probably a typo. Indeed. A trace render. I think there's still some other examples that use that we don't use anymore now. And now our UI takes on a base type, and we're back to what we wanted, which is to put effect in there, and then maybe we'll put off. And our handler also takes the base now. And that means we shouldn't have an interpreter with effect string in it, so we'll go back to the pure one. And hold on, now type is different, which I suppose makes sense, but is that because so type of send still correct? Ah, yes. So now, oh, right. So it's just what, pure unit, and we're good to go. Not exactly. So, what we need to do this again. No, that's strange. Okay, so handler. Let's look back at the code of handler. Handler now. Right, so handler used to be, let's go back to what handler used to be. Let's make this regular again. In the test, no, in Explorer actually. In Explorer, handler used to be an A, and now we take on a base action A. So wrap free val the type of send, maybe we should make it more explicit here, is actually effect cocoa free to effect unit. Is that right? This is here and one here. Hold on, I need to get back to it. So it's actually not that, and I should comment this one out. It's actually okay. Let's go back. Handler is now going to be base A to base unit. So that does look right. Base action to base unit. So base. Oh, I see. Base action to base unit. And like that. Yep. Okay. So the problem is that this is not in effect. Okay. So I just need to put a pure in front of it. And now, build code free is not the way to wrap this thing up. And to know how we wrap this thing up, we need to go back to some of the examples here. Which were very different. Actually, I've deleted them, I think, unless I have this encounter component. I do, yes, it's unfold code free. Render eval interpreter and init, which is the state. So yeah, so it's just unfold code free, and do we have unfold code free somewhere? I think it's okay, I'm not in the right place. And does it matter that it's unfold code free instead of build code free? I'm not sure yet, but I think this was here. Yeah, control command and code free trans. And did we have a? I think we also had a control command code free trans control the build code free came from control command code free. But here it uses a special one. So let's get that special one. And let's put it in control and command. And control command code free trans is going to be, oh, what's up here? Oh, unused stuff. That's fine. And for code free, and so we're not going to get build code free anymore. We're going to get control command add code free trans. We're going to get a code free instance from that. And we're going to need to Spago build. Control command add code free trans. Control command add code free trans. So does this build? Yeah, looks like it. What am I not doing right? Cannot import value build code free. Yeah, that's right. It's for code free we want. Okay. Where are we at? Still the effective identity thing. So let's see. Go back to main. Jump to the air. Yeah, so the type of step is wrong, so that should be, yeah. So that's really good, in fact, because now we get to refactor things in the way that's much clearer in my view. And so that's definitely a great thing that Arthur Xavier did for this. So let's go back to it. Counter. Separating render and eval. That's totally the good, the step, the exact thing to do, because then it makes the state to interpreter state and the state to render thing completely obvious, and that's super good. So let's pick that up and see how we're going to apply it here. So unfold code free render eval, I think, is totally the way to go. And then Indeed, where? But where what? Well, eval. Eval is fantastic, and it's going to be. Where is it going to be? It's really, I mean, is it anything else but interpreter? I don't think it is. So interpreter. We already have one of those, and then we don't need that intermediary thing. And I think this is render, right? Yes, but not exactly. So let's call it render, because it's render, but we have a state now, and the state is what? It's string, so let's just call it state here. And then that's it. And then init is going to be empty string. And then state, ooh, okay. So that's, so render takes the state. So, oh, right, of course, we need to change that type. So render now takes some kind of model, but for us it's a string. And then returns, that's what React UI is for. I see. And so what did we do with it in the end? We ended up, yeah, it's credible. It ended up working out. So let's use that. And so, right, but the action type is what? It might be Cocoa free console, blah. It's a little bit unruly, but it's also fine. How's that? Not bad. Well, we still need to import this, so it's not okay. And render function with tuple. Oh, because of what? Are you importing an old version of component? This is from React Explorer. React Explorer component. The right stuff. Oh, I say it has the right stuff, but here I'm taking base to be identity, not effect. And I don't know whether that makes sense so much. Nah, I think it does. Yeah, it does. Blah, blah, blah. We pass the base. And then what? Then we still have the same problem here. Function with tuple. Okay. Unfold co-free. Render eval. Render being function from blah to that. Okay, well, I suppose if we get our React UI wrong, then they will be wrong. So React UI takes the action, so that it's UI of effect and action. And UI of effect and action means handler base and the action. So maybe we shouldn't give the type of send. Where is there a tuple now? Yeah, no obvious. So are we using... Go free his tuple. Is that tuple we're talking about? Oh. Oh. Okay. There's another render somewhere. Yes. And that's React DOM render. So let's see. So how do we hook things up at the root with this old version? Yeah, let's just take this and main, and let's just yeah, let's just do this. Okay, maybe not. Maybe yeah, you know what? It's fine. Main effect unit and main equals what, 2, and what do we have? We have example. That's container, and then we have some UI with go-free example, and then wait case container, and we render the UI in C. Well, okay, render. So which render is that? Is that actual render then? Meaning React DOM render, counter bluff. This render is React DOM render. No, relies on React DOM render. So it's not React DOM render, it's React Basic DOM render. Aha, yes. And here I tried React DOM render with UI and C2, but it worked too, I think. Didn't it? I think so. I think it worked as well. So we could do React DOM render as well. Okay, let's do that, and then let's make a note of the fact that this can be done with React Basic DOM render as well. Case, that's where it will land. Although this looks a little bit wonky. Is this because... No, yeah, no, that's probably fine. Okay, And oh, I think we've solved this somehow, maybe. No, because we have this. Oh yeah, of course we have this extraneous stuff at the end, and unknown module DOM. Yeah, I kind of like to have this qualified, so let's have it qualified. DOM. Is that D? Maybe not. DOM was web HTML window. I see, all of this stuff is DOM. Fine. Maybe we don't have a counter. Right, so okay, so in our case we're under C, but yeah, we don't have an app. So hold on, where was that app thing coming from? App. We rendered app C in that case, and okay, yeah, that's fine. We can get rid of that. It's just UI. I can put do here and yeah, do something like this. Then we want throw probably. And then we go back to holy moly, it built. No, it didn't. Yeah, we're back to the same error. Okay. Okay, yeah, that's ambiguous, that's fine, but what I want is, yeah, no, I don't want this error. I want this one, yeah. So function with tuple, trying to match function of effect blah to effect unit. Okay, that sounds like send. Effect of co blah blah to effect unit. Okay, so maybe I'm missing something in how oh, it must be here, how send is used. Indeed, here send can be passed just a pure okay, these increments, those are monadic actions. So can I just pass pure put stir line A? That would be, it would be nice. But it would need another. Okay, but then we'd have some trouble. Let's look more closely. On click. This is in the counter example. This is Purescript React Basic DOM, so it has a slightly different. Oh no, it's not. This is React DOM. So this P on click is React DOM props. So and yeah, the synthetic mass event and whatnot. Okay, so no, so it should work. It must be just that maybe the React UI parameter is wrong. Okay, because this is, yeah, this is what the type of what my pure increment is here, right? This is, yeah, increment is of type counteraction unit, and when I do send pure, that's what I'm doing. So here, or rather here, when I say React UI Coco free console co-console unit, I should really say Coco console unit, I think is the idea. Not quite. Well, because here we say component of Cofrico console F, and I think we just need to say component of console F. Maybe not. Let's look at what the component did there. App component took a model. Oh, it returned a React component, so maybe we need to change that. Yeah, we definitely do need to. Okay, let's do that. So it's a React component of well, a co-free co-console F. I think that's right. And this would come from UI.react. This guy. Yes, it takes a W, which is passed to component T. I think that's correct. And we still have the function tuple thing, which is completely strange. So render takes a... Okay. I dislike the fact that it seems to think that it's not the same thing we're talking about. Trying to match function effect console F unit to effect unit. Focal free, render eval, render send, and div and such. Okay, maybe co-console F. Does that change anything? It doesn't. Right, because unfulcom free waits for a tuple. Okay, so yes, but didn't it also wait for a tuple right here? It did not? Holy moly, it's deprecated and replaced by build code free. So hold on, where does this unfold code free come from then? From control command code free. Oh my. Check this out. We took unfold cofree from control command cofree trans because it has one. But it's not the right one. Oh boy. That's bad. I hate this. Where was unfold cofree T used here? It wasn't used. Okay. Oh boy, that's bad. But fine, it should work with just control command cofree. And now we have a problem with our interpreter, and that's fine because the interpreter was blah to, yeah, basically the interpreter I think needed to be in the comonad, whereas here we don't build the comonad from here. But it's pretty simple to build the comonad, I think, by doing run co and making this cofree. And run co, is that? Or no, to wrap, to build a cofree. Yeah, basically need to add a cofree in front of it, but I think I did this. I think you can't because you don't have a cofree. Constructor available to you. On the other hand, no, that looks like that's the base functor. So we should be able to work with the base functor. We don't need to be in the cofree command app. Okay, so hold on. Then what's up? Why would being this is in the base functor? A function from S2. Okay. So the interpreter takes the current state as well, is what I get. And that was definitely the case of eval. Yeah. All good. And yeah, no, it makes total sense. So it's like a stateful, like we have a stateful, we have states sort of available to us. And here, yeah, it's just console F, I think. Nope. Console F, console F. I think it makes sense that the React component, oh, maybe not, maybe it should just be base functor. So if it's the base functor, what happens? And then you have some other shenanigans. It goes the other direction. Can't match, but can't match something else, I suppose. Yeah, right. Well, we don't have a val anymore. We don't need that ugly thing. think. Okay, let's look at the counterexample once more, because I didn't get the type from there, and I should have. Then pass to React, app component to React, and so that sounds fine. Right, so that is the co-free component. So we do need to be in the co-free console F right there. And so, but then that creates some other difficulty. The method type co. So then it's just that type, I think. Can we just get rid of it? Not quite. So it's not just that type. Okay, we're getting there, but definitely running on fumes. Let's drink a bit. Aha. Okay. So maybe indeed we need this here. Yes. And then our action in co-console F need in fact to be in co-free co-free console F. So we need to leave that. We can't be just in the core of the base functor. We need to be in the core of the co-free component. And so we need to build a co-free from that. And I suppose that's where like the wrap free was useful. But there must be some combinator somewhere for us here, I'm pretty sure. In the pairings. Co W is a monad, if W is a comonad, so that's the great result. And so from co, just build the co WA. On the W. But we kind of want to use this instance. Right? Hence the wrap free. Because in fact we would kind of like to be just in co-free co-console here. That'll be the easier way. And so we can try to use wrap free again. Maybe like so. Or maybe we need to do the same type of stuff we're doing earlier. In which case I should have deleted the eval. So actually I think I can go back in time to exactly that moment. Okay, except for this or this. Okay, so let's keep val. And then I think we're saying this was not co-free, but this was co-free. Console F right there. I think so. And then we pure rep free val. And then maybe we go free console F right there. And it compiles. And it builds. And it gets some state, but only the first key. What's up with that? A zero shadow. Yeah, it's fine. Ah, right. Yeah, right. So we don't get the fake because we don't use that. We just use the state. So we put the state in, but the state we should be doing, it's ignoring whatever comes in and then putting str, not shadowing it. And then no, that doesn't work. Okay. Right, so let's log. Oh yeah, we're putting a here. Yeah, what am I saying? So we need to put key in play, and that would be by giving this a string s and putting s instead, and then wrapping free val with key e, at least like so. And right, yeah, that's now an effect string that we're getting instead. Is that a problem? Not if we do this, I suppose, which is very ugly. I think there's a better way to do this, but right, no, yeah, definitely not in the right place. So we actually need to do this, and again, we can probably refactor this properly. And do. We are in the effect monad there. Yes, we are, and and then here we get back to the identity monad. Except that let's call it identity, or yeah, identity, I think. ID then no identity, but not that one, or maybe that one. Okay, ASD blah. Okay, good, very good. Except we should prevent the effects here, so event.prevent default. So however we do this, I thought that was the way. Prevent default, it takes a synthetic event. Okay. Okay, we're good. And then, yes, that's right. Then it doesn't display inside the text area. And then our state should be obviously, in fact, not identity, but str concatenated with a. And then it shouldn't start with text, it should start with well, it should really always be state. And now state moves correctly, but not the text. Why? Because that's only for the init thing. I think if we want it to be reactive, then we need to do it differently. Is that right? I mean, clearly, right? Because we, I think we had to deal with that in the chronofold example, didn't we? Not status. Let's take a look at the chronofold. Okay, here, key up text, project log. Yeah, no, not exactly. Yeah, I couldn't remember the name of the framework we used for this. It was oh yeah, SDOM, like static DOM. How come this doesn't work? It works here with pretty much it probably shouldn't be a text area takes an array of React elements, but there must be another way to specify the content of the text area. Smolder, React DOM, dynamic. Where's that? Dynamic. No idea. I think we're 610. Did exist. What's dynamic? Feels like that's what we want. Indeed, we get some stuff from there, but P, so does this explain? It doesn't actually explain our stuff. Text area, where do we get it from? We just don't specify anything. We just get P from dynamic, and that's it. Well, let's get everything from dynamic then. Seem to make a difference. We use P prime. Text area has on key press. I might want to keep that, including this too, actually. So that var thing is a little bit ugly, but again, it helps with types. So let's just keep all that around. Yeah, at some point we want this. Do the prevent default sort of extend a bit too far? I mean, yeah, no, this is just default, right? So nothing is happening. Nothing special is really happening here. So we just don't know quite how to pass text to text area. Let's see if we can find some example somewhere in the library, I suppose. Maybe in the tests. We should have some tests. React example. And text area. You wish. React to element text. Maybe. We don't need that thing. So to element. And to element. Okay. Still not. So how about like this? Interesting, huh? And then how about like this? Yeah, so it's just that we don't know how to update the text area in React. Yeah, there's probably something special to do in here, but I think that's pretty good already. Let's go back to the text right there. Yeah, we're definitely further than we've been so far, especially like we've moved. Okay, let's wrap up by writing in our log. So we didn't move on to AF, but we did do that. We looked at how Arthur Xavier does wrap free and more that free code trick, and we went further. We used the we augmented the Purescript React Explorer, Purescript React Explorer with the base with base monad and the automatic construction. So in other words, we're somewhere in between. path 31 and Arthur Xavier right now. So then next time I think we want to look at well, yeah, what do we do with effectful interpreters? Because here sand is still what feels like it's pure, but it's a bit unclear because it was always able to. It's really about what the wrap free does and how we interleave somehow the. Because sand, I'm not even sure where that we're going to use the fact that now sand somehow has a base monad. Now that I'm thinking about it, because I mean, the fact that we can change it, fine, but maybe the action doesn't need to be in the base monad. Maybe action to base unit is totally sufficient here. And if we do that, then it means that we don't need to wrap this in pure. Is that right? Yeah, I think so. Then we don't need to wrap this in pure in that case. And yeah, I don't know. So we'll play around with this. Basically, I think the main idea is how to design effectful interpreters. Console F of effects unit, or with the base functor or the base monad in handler. We don't know that, and we will find out on Saturday. So thanks, Don, for watching, and I will see you later. Bye-bye.